the global semiconductor shortage really, I think, brought forward the importance of semiconductors in everything we do, from education online, work online, entertainment online. So as people sort of settle back into their homes during the pandemic, not only was there a shortage, but that they realized how reliant the whole system was on these little amazing things called semiconductors.
I'm Steve Orlins, president of the National Committee on U.S. China Relations, and I'm thrilled today to be joined by my good friend, Paul Triolo. Paul is currently Senior Vice President for China and Technology at Albright Stonebridge Group, where he advises clients in technology, financial services, and other sectors as they navigate complex political and regulatory matters in China and around the world. More importantly, he is somebody who I rely on for advice on all matters related to technology and China. He also is a senior associate with the trustee chair in China Business and Economics at CSIS. If I went over all of Paul's accomplishments, we wouldn't have time for this interview, but he did have a distinguished 25-year career in the United States government. Today's topic is about semiconductors, which has become more and more prominent in the U.S. China relations. So let me start with a reasonably foundational question, which, it has become central. Why has it become so important in the relationship? And is this something that's new? Tell us why we've gotten to where we are today.
Sure, Steve. Thanks. And I think the timing is good, as you say. The issue of semiconductors and U.S. China relations is sort of almost every day in the media. I think you can go back as far as you want to go, but I think really the story starts in 2014 with Xi Jinping deciding to do things differently in China on the semiconductor space by establishing this National IC Investment Fund in 2014. And at that time, it was sort of a change in policy for China. But right away, the companies associated with the fund tried to acquire some big U.S. players and kind of freaked out people in the U.S., including at the time Commerce Secretary Penny Pritzker, who saw this fund as an attempt to appropriate the global semiconductor supply chain. So that sort of started off, I think, the path to where we are now. Then, of course, we had the weaponization of the U.S. semiconductor industry against Chinese companies like Huawei and ZTE in the Trump era, and then, of course, the global semiconductor shortage. So probably before the global semiconductor shortage, nobody had heard of TSMC in Taiwan or Samsung and as big players in the industry. But the global semiconductor shortage, suddenly you couldn't buy a car because the company couldn't get a chip that was critical to the functioning of that vehicle. And so the global semiconductor shortage really, I think, brought forward the importance of semiconductors in everything we do, from education online, work online, entertainment online. So as people sort of settle back into their homes during the pandemic, not only was there a shortage, but that they realized how reliant the whole system was on these little amazing things called semiconductors. And then I think finally, the final sort of thing that brought it to the fore is Taiwan and the centrality of Taiwan in general, and TSMC, the Taiwan Semiconductor Corporation, to the whole global semiconductor supply chain. And of course, Taiwan, as you well know, Steve, is now sort of in the middle of U.S. China relations. And so I think the realization that suddenly that all these advanced chips, the type that are in your smartphone or in data centers and other places, are all manufactured in Taiwan. That sort of came just really in the last 2 years into people's consciousness, and particularly in that of the U.S. government, which of course became increasingly concerned about the concentration of those capabilities in Taiwan. So all those factors, I think, over the last four or 5 years have contributed to sort of raising the spotlight on the semiconductor industry as a whole, and then Taiwan in particular.
The Chinese government, as you just mentioned, started with the creation of this fund in 2014. Have they succeeded?
That's a great question. I think the jury may still be out on that. There have been some successes of the deployment of funds as part of this National IC Fund. For example, a Chinese memory maker, YMTC, is actually now producing competitive memory modules, 3D NAND modules that Apple has been trialing for its iPads and iPhones. That's arguably a success of the funding and some of the policies around the National IC Fund. But on the other hand, there's been a tremendous amount of waste and fraud and failed projects that have been generated by that National IC Fund. And so over the last 6 months, for example, the Chinese government has launched this huge corruption probe that's targeted almost all the important officials associated with this fund. And we think that's largely because the Chinese leadership is not satisfied with the success of this fund, and that the funds have not been spent wisely. Maybe there's been too much focus on manufacturing and not enough on other areas like manufacturing equipment, for example, where China lags behind the world. And so it's sort of a mixed bag. I would say in part it succeeded, but we're talking about a lot of money that was not really spent effectively in this sector to really improve China's domestic capabilities. So I think that going forward, the government will be looking at other new ways to figure out how to drive capital into the sector. They're using the stock market in Shanghai, for example, the star market, and trying to use more market-driven mechanisms. Because the bottom line is, this is a very, very market-driven industry. And so government planning and government subsidies aren't necessarily the way to go here, because they don't necessarily produce competitive companies.
Yeah, so how much have they spent?
Well, it's a good question. The initial IC fund was around $50 billion to $100 billion, depending on how you calculate the provincial versions of this and the municipal versions. So they've probably spent upward over $100 billion probably likely on this. And China is probably the only country that could spend that much money and maybe not have as much to show for it as other countries where it's the sector is market driven and companies are very careful about their capex expenditures. The problem is that this is a very capex and R&D driven industry, and so those expenditures have to be done wisely. And I think China has, the country has been awash in money on this, but the problem has been more around the technology, lack of technology innovation, lack of talent and managerial talent to really drive the industry, and just good business models. Really, I mean, that's been the underlying problem here.
People in the industry have explained to me that when you do R&D on new chips, it's a whole ecosystem. It doesn't sit in one place or even in one country, that it crosses boundaries. It involves scientists and technologists and others. Can China ever succeed? And isn't the success that you pointed to in relatively simple chips?
Well, not the YMTC is making fairly sophisticated memory chips, but yes, I mean, I think you're exactly right. The industry is globally distributed. There's sort of a global division of labor. The process gases and wafers and some of the inputs, the upstream inputs, for example, come from Japan, and even from China and South Korea, other countries. Manufacturing is largely the purview of Asia right now, although there's some done in U.S. and Europe. And then the manufacturing equipment, for example, is largely coming from the U.S., Japan, and the Netherlands. So it's been a very geographically distributed and concentrated industry. And for China to try to recreate all parts of this very complicated set of supply chains is really, in fact, it's sort of impossible, right? Because you need to have, again, you need to have the people, you need to have the technology. And so China can succeed in some parts of this and has made a lot of progress. I mean, you have to sort of look at this, step back and say 10 years ago, China wasn't anywhere in many of the subsectors of the semiconductor industry, and now they have really good design firms, for example, and they have a fairly good manufacturing company in SMIC and some other smaller companies. So they've come a long way, but the problem is it's a global industry, and the costs for competing at the cutting edge, for example, are very, very high. And so for China to try to do this on its own is really, I don't think there's enough money really to do it. And then again, it's not really so much the money, it's the people and the technology and the trust of clients and customers around the world, for example, to use your supply chains and your facilities. And that China has had a hard time in that too.
How should the U.S. be responding? Yesterday, we heard Secretary Raimondo call out the China's threat during comments about the CHIPS Act, which, as we all know, passed last summer and is the centerpiece of the administration's industrial policy. Is this the way the United States should be responding? And is it a response to China or something else?
That's a great question. I think a lot of the media stories around the CHIPS Act and a lot of the administration rhetoric has been focused on China and competing with China. And at one level, that's sort of true in terms of the subsidies, for example, that have been provided by the Chinese government. The U.S. is basically getting into the subsidies game a little bit late. Most other developed countries, not just China, but including Israel and Germany and Taiwan, of course, and South Korea and Japan, all to some degree subsidize their industry. So that at one level, the U.S. is sort of catching up. But really, if you look at competition, there are very few Chinese companies that are competitive in any parts of the global semiconductor supply chain. So really, I've written about this quite a bit, really what the CHIPS Act is about is trying to reduce the dependence on Taiwan, of course, indirectly because of China, because of the potential threat from China of some sort of forced reunification of Taiwan. So the CHIPS Act is designed to reduce this overwhelming dependence of the global industry on Taiwan and TSMC for the most advanced semiconductors, the type that's in your iPhone or your Android, where TSMC produces something like 92%, depending on how you count it. And the CHIPS Act is really designed to, over time, slowly reduce that dependence on Taiwan, in part because of this concern that by 2027 or 2030 or 2035, that China will make some moves to move towards unification of Taiwan, either peacefully, or in the worst case scenario, militarily, that would then sort of take Taiwan or reduce the potential for Taiwan to continue to play that vital role it has been in the global industry.
If it's militarily, those CHIPS facilities don't exist anymore. That the idea that you would have a military takeover of Taiwan and these facilities would remain undamaged is just not logical.
And Mark Liu, recently, during the Pelosi visit, as you remember in August, one of the senior officials at TSMC reminded people that yes, the TSMC is sort of real time connected to the global economy. It has upstream gases and materials coming in and tools coming into the facilities, and then it's shipping out a product. So it really can't exist without Taiwan, being fully connected to the outside world. Everything that comes in and out of there, most of it is by air. All the semiconductors are shipped by air, for example. And so, yeah, TSMC couldn't really last for a day without that continuous supply. So the idea that China would somehow march in and continue to run those facilities is probably quite fanciful.
So one would have to think about some level of peaceful reunification and then taking over these facilities. It's kind of pretty science fiction-y.
Well, I think, yeah, it's something that was, not on the radar in the sort of wargaming and discussions about crisis in the Taiwan Strait 10 years ago. But now it's a really big issue because Taiwan and TSMC are such critical pieces of the global supply chain. So the circumstances now of unification become really critical. Is it something that happens relatively peacefully? You don't have a flight of engineers, for example, out of Taiwan, because again, those facilities, not only can they not operate without the sort of equipment and materials coming in, but obviously the people. That's where Taiwan and TSMC have excelled, is they have top-notch engineers, and they're highly concentrated. And if you create conditions on Taiwan where unification is not peaceful and it's not is not something supported by the people of Taiwan, then the odds of you being able to run those facilities, or anybody being able to run those facilities, becomes very, very, very low.
Yes. How did TSMC become so critical in this industry?
That's a great question, and it sort of snuck up on us, I think, too. I mentioned earlier that people sort of suddenly realized how important TSMC was. To those in the industry, it wasn't a secret, but it happened over time, and it really was the result of the dominance and the sort of brilliance of this model that was created by Morris Chang, the founder of TSMC, of the foundry model. So basically, the idea was that instead of a company like an Intel, which designs and manufactures its own semiconductors, a so-called called integrated device manufacturers, that a company like TSMC would focus just on the manufacturing side. It would make designs that other companies would facilitate. So, for example, Apple and Qualcomm and Nvidia, the success of those companies has been driven by the fact that they don't have to invest in manufacturing. They can take their designs, they can focus on the designs of their iPhones or their GPUs or whatever they're making, and they can have them made at TSMC with the most advanced manufacturing processes, because that's what TSMC specializes in. And so that model, which involves a lot of trust, right? There's a lot of IP floating back and forth. That model of sort of client service to really cutting edge customers, and then on the backside, working with the tool makers, which are all, again, largely U.S. companies like Applied Materials and Lam and ASML, which is a Dutch company. The TSMC also works with the tool makers to incorporate the latest advances and make sure those tools all work together. And so that model of trust and sort of customer service and sort of the back end collaboration has really driven innovation in the industry. And that's what allows you to have such a powerful device in your hand here with the amount of computing power here. It's really because of that, in part, mostly of that TSMC model. Now, there are other semiconductors in there that are very advanced, but the core chips there are because of TSMC's business model that was pioneered by Morris Chang and has really sort of come to dominate the industry. Intel and Samsung, which are the two other leading players, are both getting trying to further get into the foundry business, because that just turns out to be a really, really good business model.
Trying to put politics aside, which is, I know, almost impossible when we're talking about U.S. China relations, is the CHIPS Act good policy?
Well, it's a good question, Steve. I mean, at one level, yes. I mean, the U.S. is lagging in the sense in manufacturing. There's no doubt about that more broadly, because a lot of the offshoring that occurred over the last 20 years sort of hollowed out the U.S. domestic manufacturing sector in general, and semiconductors in particular, because of things like high costs and the need to train lots of really qualified engineers. And so a lot of the offshoring went to Taiwan, went to China, went to South Korea. And so one level, yes, it's a good idea to try to jumpstart the U.S. domestic industry. The problem is you're doing that at a time when the cutting edge, for example, which is the focus of the CHIPS Act, it's really expensive, right? The CapEx expenditures for a 2-nanometer fab are like $40 billion. And so at one level, it's good, but another level, the challenges of sort of, in terms of spending enough money, the costs in the U.S. are much higher than places like Taiwan and China. And then also, again, the talent. The U.S. has lost the ability to produce. The system doesn't produce enough STEM people that do hardware engineering. And so at the same time, as the U.S. wants to do manufacturing, it has to recreate, like China, all these other pieces of the supply chain and attract the suppliers to TSMC and Samsung and Intel to come to the U.S. and recreate all those supply chains at a time when the costs are really high. So you're sort of reversing the offshoring, which was done for economic reasons. It sort of makes sense, right? And now you're reversing that. And the economics, look a little bit challenging. But I think in general, there's consensus in the US that, this is a 10-year project that will eventually, boost the US's manufacturing capability and also improve things like R&D and also workforce. The workforce piece of the CHIPS Act, for example, is really, really important. And Gina Raimondo has been, the Commerce Secretary, has been really adamant. And all the proposals for getting CHIPS Act funding, for example, will include a workforce component. How are you going to train the workforce to do this? How are you going to improve the ability of the U.S. to supply the workers and the engineers that you need to run those facilities? So that's, I think it's a good thing over the long term. The problem is the sustained commitment to that, right? These countries like Taiwan, Japan, China, of course, they do industrial policy and they know how to do it over the long term. There's still some skepticism, particularly in Taiwan, that the U.S. is really committed to this because this is really a long-term effort.
Yeah. Are our subsidies less than, equal to, or greater than those of the other countries? And how much are they?
Well, right now, the CHIPS Act is about $39 billion of the original money that will go to manufacturing. And that's, in an industry that's going to spend something like $1 trillion in CapEx to 2030. It's not that much, but the administration sees it as sort of a down payment for funding that will attract companies like TSMC, like Samsung, like Intel to site more facilities in the U.S. in the next 5 to 8 years. And then there'll probably be an attempt in 2026 when the CHIPS fund, the initial money runs out, to get further funding there. And I think the hope is that this will catalyze more private sector investment as you start to get more companies building facilities in the US, you get some economies of scale, and you get sort of a virtuous cycle of clusters. So in the US, for example, we'll have clusters in Arizona where TSMC and Intel have fabs and other companies, and then in Texas with Samsung, and then probably in Ohio where Intel is building facilities around Ohio State. And then in New York and in the Albany area where there'll be some R&D money from the CHIPS Act that will go in. So if you look at the overall amount of money, it doesn't seem like that much compared to the bigger industry capex expenditures over the next 10 years. But I think, again, the administration views this as a necessary down payment, and it will seek other ways to continue to provide funding and continue to attract companies to site facilities in the US.
It's interesting that here we are subsidizing, obviously, companies that are earning tens of billions of dollars. These are some of the most profitable companies in the world. At the same time, we're kind of taking from their profitability through export restrictions on chips to China. How did these two things relate? I remember in the
That's a great question.
The Pentagon would kind of say, well, these restrictions are going to affect our company's abilities to do R&D for the advanced chips that we in the military need. So they were kind of the last pillar in opposition to export restrictions to China, but that's now faded away. So talk about that issue.
That's a great question, Steve. And I think, this is the argument that the industry has been making over the past 2 to 3 years, which is if you move to cut off pieces, large chunks of the China market from US companies, and a good example there is Huawei, the restrictions on Huawei, which were never really clarified in terms of the scope of those. Why did they include consumer devices, for example? And the result of that was to cut off significant amounts of revenue from U.S. companies, leaders in the semiconductor industry, that they could not then plow back into R&D. And so the argument here is that you can control certain types of semiconductors going to certain Chinese end users, but some of the controls have been implemented in ways that have really damaged U.S. businesses. Most recently, for example, you have a ban. It looks like a ban on certain GPUs going to China from NVIDIA. NVIDIA in a recent
GPU. Tell us what a GPU.
The GPUs are graphic processing units, and they're used. NVIDIA and AMD are the world leaders in these, and they're used in a variety of applications, including for AI training in the cloud, for example. And the U.S. government has become increasingly concerned about the potential diversion of some of these systems to the Chinese military to be used in things like high-performance computers to design modern weapon systems. So just in August, the Commerce Department sent letters to AMD and NVIDIA saying, basically, at some point, you will no longer be able to ship some of their most advanced systems to China. Now, NVIDIA said right away that was going to cost them $400 million on a quarterly basis, potentially, depending on how this is implemented. So that gives you a sense. And then the other example would be Intel, which derives about 30% of its revenue, its global revenue, from China. And so a lot of the money they're going to invest, for example, in those new fabs in Ohio is coming from their sales in China, where they dominate the server market, for example. Their Xeon CPUs are the dominant data center application and semiconductor in China. So there's a very tight connection between leading U.S. semiconductor companies like Intel, like AMD, NVIDIA, and the China market. And so at the same time as you're encouraging more manufacturing in the U.S. and more siting of facilities in the U.S., the worry is that if U.S.-China relations lead to a further deterioration, a significant deterioration, and even to conflict over Taiwan, and China gets sanctioned, for example, in the same way that Russia is, that you're going to be, sort of slowly cutting off that market from U.S. companies, which are using that revenue that they derive from the China market to drive R&D, which benefits and creates jobs in the U.S. and helps keep them as global leaders in the industry. So that dynamic is a very important one to watch, because you don't want to be sort of shooting yourself in the foot on the one hand, at the same time as you're trying to rejuvenate your domestic industry using some of the same companies.
So in a way, we're having the taxpayers subsidize an anti-China policy.
Well, it's interesting. The issue of it's become a little bit about political football, right? Well, why is the U.S. government subsidizing these successful companies? But again, I get back to my original a comment about industrial policy is that in other countries, including Taiwan, including South Korea and Japan, government subsidies provide a really critical sort of margin for those companies that are building these very expensive fabs. So if you're building a $30 billion fab, for example, and you get $5 billion in subsidies and tax incentives and other credits, that makes a huge difference in terms of how you can plan to build that and the profitability of these firms. Because again, it's a tricky market here. It's very cyclical, and you can have a downturn in the market. People aren't buying smartphones or PCs, and so over the long run, those government subsidies play an important role in keeping those companies economically viable, able to continue to invest in R&D and continue to sort of move forward and innovate. So that money is pretty well spent, one could argue, if it results in these companies being maintaining their innovation capacity and leadership in these key markets.
By the way, is it done in the form of a grant, a loan? What's the form that money is going to take going to these companies?
That's a good question. The CHIPS Act is a combination of things. So the CHIPS Act does have some outright grants, but an important part of the CHIPS Act is the FABS Act, which is a tax incentive. It's a tax credit essentially, and companies really like that. So the tax credit part of the CHIPS Act funding is going to be less politicized. Anybody who's building a facility can get those tax credits. The actual other part of the CHIPS Act is going to be companies applying to get those grants and other incentives to the Commerce Department, and that's going to end up being a little bit more politicized because it will be Samsung and TSMC and other foreign companies trying to get some U.S. subsidies here, and that's generated a lot of political concern in Congress. But so there's two different pieces to that, but those will be combinations of incentives, and then there'll be also some things like around workforce to promote the workforce development in the U.S. that will also be are also included in the CHIPS Act, and that will be in the form of grants and other incentives to universities and to do STEM, to boost their STEM programs there. So it's a variety of things, but a lot of it comes down to outright grants or tax credits.
What should the good policy be that divides first semiconductor manufacturing equipment from semiconductors, and then among the different kinds of semiconductors, which should be subject to export restrictions, which should be allowed, and to some degree figure in the restrictions incentivize the Chinese to create their own ecosystem to manufacture those semiconductors.
Right, that's a big topic. I think we could spend a whole hour on that, but I think basically what's happened now is the U.S. government has decided to basically take measures to really significantly slow down China's semiconductor industry. And so this means restrictions and existing restrictions that are in place and new restrictions around those semiconductor manufacturing tools, which again, US and Japanese and Dutch companies dominate. And so already, for example, the very high-end equipment, the extreme ultraviolet lithography equipment, which is really allows companies to do cutting-edge manufacturing, is restricted going to China. And then now there's an effort to restrict even older lithography equipment, for example. And essentially what the US government is trying to do in conjunction with allies is to cut off China's capabilities at around 14 nanometers. So the most advanced nodes, for example, in your phone and in other advanced equipment are right now around 5 nanometers and moving towards 3 and 2 nanometers. So the goal of the US government is to sort of freeze China around 14 nanometers and above, so-called more mature nodes. And then also for memory, to freeze China somewhere in the memory space around 128 layers, which is a measurement of the sort of density of memory chips. And so we're going to see probably in the next couple of months some new restrictions on this, working with allies. And again, as you know, the result of that is going to be to drive China's domestic innovation to try to replace those tools and to develop its own capabilities. That's going to be a long-term effort, though, because most of the Chinese companies, for example, in the manufacturing tool space are 5 to 7 years or more behind their US and Japanese and European counterparts. So it's going to be a tough haul for China, but already you're seeing a huge shift in investment in China into semiconductor startups in the tool sector, right? So that's going to be interesting to see if China can recreate, for example, that whole supply chain around tools. And it's going to be very difficult to do. But the U.S. is moving in the direction of cutting off those advanced tools, and so China's going to have to respond. But it's going to be a long-term effort to do that. And that, again, that's the argument against these kinds of measures. It's going to make China less dependent on U.S. technology, on U.S. manufacturing technology, and it's going to ultimately undercut to some degree the business models of leading U.S. companies like Applied Materials or like Lam Research and like KLA Tencor, which do make all the tools, and some of the EDA tool companies too that do the design software. So it's a tricky policy the U.S. is pursuing. The question of whether it's well thought out over the long term and how it's going to impact both U.S. industry and China is not clear to me.
We're out of time, so let me just ask, are our allies on board?
That's a great question, Steve. It depends, because one of the things I'll point out is that South Korea, for example, does not seem to be on board with some of these new controls being implemented around manufacturing tools. They have facilities in China, in Wuxi, for example. SK Hynix is a big memory maker, and they're something like 40% of the DRAM market, this dynamic random access memory market, is in China, in companies, both Samsung and SK Hynix facilities they're running in China. And they sunk a lot of capital into those facilities, but now because of these new controls, they can't upgrade those facilities. And so they're really not happy about that, the South Korean government. So no, I would say in the case of South Korea, they're not really on board with this. Taiwan also is sort of reluctant, one could argue, in terms of citing a lot of new facilities in the U.S. That TSMC, given its own druthers, I think would much prefer to stay in Taiwan, where they have a lot of advantages and they know how to expeditiously and commercially expand their capacity in Taiwan. U.S. is sort of a different animal. The culture is different, the costs are different, and so they're doing this because they're under pressure from the U.S. government to site advanced facilities in the U.S. But they probably do not really want to do much more than maybe one gigafab in Arizona. And so it's going to be interesting to see over the next 3 to 5 years how many companies from those Asian giants like Taiwan, Japan, and South Korea, the U.S. can attract to come to the U.S. I think there will be an initial uptake, but then it's going to be tough because those other issues kick in, like costs and workforce and other issues that are really tricky to solve.
Well, this has been phenomenal. I have learned an extraordinary amount and have proven why I rely on you for all of the questions I have about China and technology. This was truly terrific. I can't thank you enough for doing this and for what you do for the National Committee all the time.
Thanks,
you.
Steve. I really appreciate your leadership in all these areas and enjoy working with the committee very much.